In today's video, we'll be diving into the topic of rate limiting. We'll discuss what rate limiting is, why it's important, how it works, and its various applications. So let's get started. Digital resources are finite in nature, like an application programming interface, or API, for example. It will only be able to handle so many requests per minute or hour, assuming it's deployed on a fixed amount of infrastructure, like one virtual server. To prevent overloading this resource and ensure its reliability, rate limiting comes into play. Rate limiting, sometimes referred to as throttling, is a practice that restricts the number of requests a user can make to a digital resource within a specific time frame. So how does this happen exactly, you may ask? Well, rate limiting is a set of rules that control the rate at which a user can access a digital resource. It's typically based on a user's identification, such as their user ID or Internet Protocol address, or IP address. A rate-limiting solution tracks the requests made from each IP address and compares the activity against the defined policies. For example, how many times can a user attempt to log into a website in a minute? Without rate limiting, the answer might be as many times as they want. However, with rate limiting in place, the answer could be the user can attempt to log in up to 3 times in a given minute. If they exceed this limit, they will be blocked from further attempts. It's important to note that rate limiting can be implemented in different ways. Besides limiting requests based on frequency and total volume within a defined time frame, rate limiting can also be applied based on location. For instance, different limits can be set for users from different countries, or requests can be rerouted to different servers based on the workload. It's also important to note that rate limiting serves multiple purposes. First and foremost, it ensures reliable access to digital resources while meeting service quality expectations. By implementing rate limiting, system owners can prevent resources from becoming overwhelmed by an excessive number of requests, which could lead to service slowdowns or outages. This practice also helps system owners avoid investing in unnecessary infrastructure. From a cybersecurity perspective, rate limiting plays a crucial role in protecting digital assets from malicious or unauthorized use. It acts as a countermeasure against threats like denial of service attacks, which aim to flood a resource with requests to shut it down. Rate limiting can effectively block such attacks, ensuring the resource remains accessible to legitimate users. It also mitigates brute force attacks and credential stuffing, where attackers attempt to gain unauthorized access by rapidly guessing passwords or using stolen credentials. Rate limiting is not only important for service quality and cybersecurity, but it also has financial implications. Efficient utilization of digital assets can lead to better financial outcomes. By keeping resource usage within predictable bounds, rate limiting helps businesses avoid unnecessary investments in additional infrastructure to handle high volumes of traffic caused by unlimited access. It prevents wasted expenses and optimizes financial efficiency. In conclusion, rate limiting is a crucial control and countermeasure for system owners who strive to ensure security and maintain service availability. It plays a significant role in achieving desired financial outcomes by optimizing resource utilization. While the concept of rate limiting is simple, its implementation requires attention to detail and effective policy enforcement. By implementing rate limiting, system owners can ensure that their resources are accessible to those who are entitled to use them. To see how Noname Security can help you discover APIs before attackers do, analyze API behavior, and remediate any source of API risk, visit nonamesecurity.com.